Welcome back to Doc's Hot Shop and Forge. Today we're going to take the bar that we forged in the last video of the treadle hammer build, link there, I think, and make it into a set of plain forging dies. As you'll recall, the steel that we ended up with is 25 millimeters by 32 and 130 millimeters. This thing's dying. Long. Sorry, you couldn't see that. This will provide the top and bottom die. The top die will be mounted to a small box, approximately 40 millimeters tall, of the same steel that I've made the socket for the hammerhead. It will have 2 set screws front and back to lock it into place, because the hammerhead actually has this lovely little keyed groove in it. To the bottom of this will be welded an anvil plate of 16 millimeter steel, and then half of one of these will be welded, quite possibly at an angle, so that I can stand at an angle and work. I don't have to stand directly in front. I'll have to tweak that a little bit to find the optimal angle. The bottom plate will be, I really need to replace this, 16 millimeter anvil plate. There'll be a back skirt, a front skirt, and then 2 keying pieces that go down either side of the rail that is the anvil. These will have set screws to lock it into place. So this is going to be largely fabrication work. There'll be a little bit more forging on this, I expect, because it's not quite rectangular, but it's close. It'll lose about 1 millimeter in height, I reckon, which I could just grind off. We'll see how we go. So, let's get started. Okay, so we have to turn this into 2 dies. These are going to be our set screws. They are grade 8 M6s, so should have the strength to hold them, I hope, and we'll see how we go. So we have a lot of welding and a little bit of drilling beforehand, but I'll do the drilling for this one after, because I need, actually I'll probably drill this one after as well. No, I'll drill this one first, so I know exactly where the holes are, and that way where the mating blocking divots in the anvil are, so that for future dies all I have to do is duplicate the measurements. Let's get to it. So that's the bottom die. Once these are done up, it's actually very secure, especially once you do them up with the spanner. Doesn't move, so that's ready to receive the die piece. Now I've got to fabricate up the one for the top. Chose to do the bottom one because I thought it was going to be the most complicated one. Turns out I was probably right. It's not the simplest thing. The welding sucks, but it should hold up. So we've got the chassis for the top and bottom dies, which fit pretty well. So now we just got to grind the actual metal for the die to give it a good flat surface, clean it up so it's got a good surface for welding, and decide on what angle to put these at. Clamp them together, wedge this closed, tack, tack, tack them both into place, and alright, so now we've got it reasonably flat. Try to cool it off a little bit, flip it over, clean up the chamfers and the bottom so we get good contact when we're welding. And we're going to have a reasonably deep root pass and then a nice fillet. So at least that's the hope, or the aim. So I'm going to approximate 30 degrees. I've got close to 80, so I'm going to go with the 1:2. Where? Otherwise, face like me. So now, what is this? That is 8, so 8, 39. So, this one is, should be. Should be close enough. Probably a little bit away from 30 degrees. It's pretty close to the coming out. It still allows me straight. The dive like this. Where it comes in. That works. That should be. That should be close enough. It's probably a little bit greater than 30 degrees. It's pretty close to perpendicular to the angle I come in at. It still allows me straightening. So if you imagine the die is like this, where it comes in, or so that works. So that's the die blocks ready to be welded in. So I will need to find a way to secure this one down whilst we tack things together. So we've begun heating the dies up to get them up to an annealing temperature, and then we're going to let them slow cool at the forge for the rest of the day, and then tomorrow we're going to heat treat them. So, we're about to heat treat the forging dies. So this is canola oil. It's the largest canola oil bath I've made. It's about 2 gallons, which I think is probably on the light side for the size of these. But we'll see how we go. They'll be tempered back at 220 degrees Celsius, which is about 430-ish Fahrenheit, so it should be a straw colour. Seeing as these are actually forging dies and they are from 140, so it should be about right. It's about the same temper I use for most of my hammers. So I'm just waiting for the forge to come up to temperature before I put the steel in. Really close. Okay, this is the most dangerous one because of the hollow. So this one is pretty close. Last one. Okay, let's get these in the oven. These dies have come out looking good. There doesn't appear to be any warping post heat treatment. So now it's just a matter of mounting them and seeing how they work. I'll have to leave that for a few days as I'm in the process of making some other tools for the treadle hammer at the moment. But I will show these being used, possibly for making some tongs. We'll see. If you'd like to support the channel, I now have a Patreon. Any donation will be just that, a donation. The content will always be free. The Patreon link is in the video description down below. If you've enjoyed this video, hit the thumbs up. Feel free to share on social media. And if you haven't already subscribed, I'd love it if you hit the subscribe button. Don't forget to ring the notification bell to know when I've uploaded the next video. As always, get out to your shop, have fun, but do stay safe, and I'll catch you for the next one.